Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera everyone. So today we're going to discuss about subtopic 8.4 composite material and its important. First, let's we go through the learning standard for this subtopic. At the end of the lesson, people are able to 8.4.1 state the meaning and the properties of composite material. 8.4.2 describe with the example of uses of composite material. 8.4.3 compare and contrast the properties of composite material with its constituent material. Okay, let's proceed with the definition for composite material. So what is composite material? So composite material is material made from containing two or more non-homogeneous substance that is matrix substance and strengthening substance. So you guys can see the illustration that I show you guys. Okay, you can see this one is the example of composite material for wood, where matrix substance is called lignin for wood and strengthening substance is cellulose fiber. So the combination of matrix and strengthening, which is lignin and cellulose, will produce a composite material. It's called lignocellulosic material, which is wood. Okay, so the matrix substance surround and bind the strengthening substance together. Okay, so let's proceed with the composite material and their uses. Okay, the first composite material is reinforced concrete. So what is reinforced concrete? How it's produced? So reinforced concrete is produced when steel bar or wire mesh, which is strengthening substance, is immersed in the concrete, which is matrix substance. Means that we add the steel bar or wire mesh into the concrete. Okay, where the steel bar or wire mesh is strengthening substance and concrete is called a matrix substance. So reinforced concrete is widely used in the construction of bridge, dam and building. Okay, once more, reinforced concrete is widely used in the construction of bridge, dam and buildings. So you can see the example. Okay, I show you a picture. This one is KLCC Tower at the Kuala Lumpur. So a part of buildings is actually made up from the reinforced concrete. Okay, so that's why it can long lasting and then still exists until today. Of course, you can see another example is bridge. Okay, that one also we use the reinforced concrete to make this one dia punya tiang tu. Okay, you can see for example Jabatan Pulau Pinang kan. Okay, so you can see the pillar here is made up from the reinforced concrete. Okay, let's proceed with another composite material. Okay, so fiberglass. Fiberglass is also known as a composite material. So how fiberglass is produced? So as you can see, fiberglass is produced when plastic, which is our matrix substance, okay, is strengthened with the glass fiber, which is strengthening substance. Okay, so this composite material is used to make helmet, car bumper and printed circuit board. Okay, so helmets, okay, obviously everyone know helmets. Okay, when you want to ride the motorcycle, so you need to put a helmet you need to wear the helmet first because the safety is first. And the car bumper, semua dah tahu kan car bumper ni apa. And the printed circuit board PCB is used widely dalam kita punya smartphone, okay, computer reader dan sebagainya. Right? So you need to remember that fiberglass, dia punya matrix substance is plastic and the punya strengthening substance is glass fiber. Okay, so let's we proceed with another composite material, which is optical fiber. Okay, so optical fiber consists of 3 layers. The innermost layer is the core that is made up of silica glass fiber. Okay, so the innermost layer is made up of silica glass fiber, which is strengthening substance. Okay, you need to remember, for optical fiber, strengthening substance dia adalah silica glass fiber, which is innermost layer. The core encased in a second layer or cladding that is made up of glass or plastic, which is matrix substance. Okay, you need to remember, second layer is made up from glass or plastic, which is matrix substance. So, for optical fiber, matrix substance dia adalah glass ataupun plastik for the second layer lah. Okay, macam kita tahu innermost layer, okay, yang itu dibuat daripada silica, which is strengthening. But for matrix, dia dibuat daripada glass ataupun plastik. The outermost layer is made of plastic that act as a protective jacket. Okay, so outermost layer for optical fiber is made up of plastic, okay, act as a protective jacket, which is also known as matrix substance. Okay, sama seperti second layer tadi. Okay, optical fiber are used to transmit information and data in form of light. Okay, so optical fiber ni selalunya kita tengok, kita dapati banyak lah untuk dia nak sambung yang internet punya kan. Okay, so kita pakai optical fiber lah. Okay, so light move through the optical fiber in a series of total internal reflection. Okay, the core and the cladding have a different refractive index to enable them to carry data in large capacity and to not be influenced by electromagnetic disturbance. This composite material has replaced copper wire in video camera and connect computer in a local area network. Okay, so you need to remember, for optical fiber we have 3 layers. The innermost layer is made up from silica, which is a strengthening substance, and the second layer or cladding, okay, that is made up from glass, which is we call matrix substance, and outermost layer, okay, is made up from plastic that act as a protective jacket, also known as matrix substance. Okay, so as we can see the picture here, this is the example of optical fiber. Okay, alright, so we proceed with the next composite material, which is photochromic glass. Okay, so what is a photochromic glass? Okay, how photochromic glass form? Okay, photochromic glass is formed when glass as a matrix substance is combined with silver chloride. You need to remember, glass, which is matrix substance, is combined with silver chloride and copper chloride. Okay, CuCl, copper 1 chloride, as a strengthening substance. Okay, so matrix is glass for photochromic glass. Silver chloride and copper chloride is strengthening substance. So, when exposed to sunlight, okay, photochromic glass darkened. You need to remember, when exposed to the sunlight, photochromic glass is darkened. This is due to the formation, due to formation of silver atoms that prevent the passage of light. That's why photochromic glass become darkened when we expose to the sunlight. In a dim light, copper chloride in photochromic glass catalyst the reverse process, so the glass become transparent again. So you need to remember this one. Right? Photochromic glass protect the user from UV rays, and it's suitable for use in car windows, building windows, and the camera lens. So as you can see, the picture given here, this is the example of photochromic glass. It's very near with our life. Dalam hidup kita pun ada ni, sentiasa kita pakai, kan? Dekat je dengan hidup kita ni. Alright. So we proceed with the next composite material, which is superconductor. So what is superconductor? How superconductor is made up? Superconductor such as yttrium barium oxide, yttrium barium copper oxide, YbCO, ceramic, is a composite material that has superconductivity properties other than alloy. Other than alloy. The superconductor is used to make electromagnet that are superconductor magnet or supermagnet. Superconductor magnet are light. You need to remember, superconductor magnet are light and have a strong magnetic force. Superconductor magnet used in particle accelerator and involved in nuclear magnetic resonance, which is NMR, machine, and magnetic resonance imaging, MRI machine. So as you can see, kalau untuk magnetic resonance imaging, MRI, so bentuk dia macam ni lah. And then for nuclear magnetic resonance, selalunya machine dia dalam bentuk macam ni. So bila kita sebut saja superconductor, dia punya example adalah yttrium barium copper oxide YbCO, which is a composite material that has superconductivity properties other than alloy. So this is the uses for the superconductor. So we proceed with the compare and contrast the properties of composite material with its constituent materials. So constituent ni maksudnya dia punya komponen lah. Alright. So kita tengok dulu comparison reinforced concrete with its original component. So as you know, concrete ni, concrete can withstand. Kalau tengok dekat dia punya properties, as you can see dia punya properties, can withstand high compressing strength. But, unfortunately, will break if is subjected to high stretching force. Itu untuk concrete kan. Dia tak ada yang stretching strength. As you can see, low stretching strength. So maksudnya when we apply high stretching strength, stretching force, dia akan menyebabkan concrete tu tadi akan break up. So susahlah macam tu kan. And then another lagi properties yang baik untuk concrete is resistant to corrosion. So in order to overcome the disadvantages which is low stretching strength untuk concrete ni, kita tambah pula dengan steel bar, or wire mesh, which is yang ni dia high stretching strength, but dia pun ada disadvantages which is corrode easily. So from this combination, concrete and also steel bar or wire mesh ni, dia complement each other, and then dia boleh overcome dia punya disadvantages tadi lah, and then dia jadilah which called reinforced concrete, where the properties is high compression strength, high stretching strength, and also resistant to the corrosion. So ini adalah dia punya comparison between the reinforced concrete with its original component. Okay, so we proceed with the comparison fiberglass with its original compound. Okay, so as you can see, plastic, the properties is low stretching strength, low heat and electrical conductivity, resistant to corrosion, and durable. So as you can see, we have two disadvantages that we need to overcome, which is low stretching strength, low heat and electrical conductivity. So in order to overcome these advantages, okay, we'll combine with the glass fiber, which is high stretching strength, and low heat and electrical conductivity. So from that, okay, from this combination, we will get the fiberglass, okay, which is the properties high stretching strength, heat and electrical insulator, resistant to corrosion, and durable. So resistant to corrosion, durable, and a heat and electrical insulator, this one is come from the plastic, okay, dia punya properties. So high stretching, it's come from the glass fiber, so it's complement each other. So you know, the plastic ni adalah dia punya matrix kan, okay, and the glass fiber ni adalah dia punya strengthening substance. So plastic matrix ni consists of plastic that is weak lah, okay, soft and easily to burn. So that's why dia ni ada low heat and electrical, bukan, okay, so weak, soft and easily to burn, okay. So the property of plastic tadi tu, dia mesti reinforce, mesti kena ada penambahbaikan lah, by adding the glass fiber, macam tu, right? Okay, so seterusnya kita pergi kepada comparison between optical fiber with its component. Okay, so for optical fiber ni, optical fiber has high compression strength, although the original component that is glass fiber is brittle. Okay, so yang ini pun dia lebih kurang sama seperti yang atas tadi, right? Okay, where plastic, okay, kalau tengok dia punya properties high compression strength and also flexible. And then for glass fiber, low compression strength but hard. Okay, so in order to complement each other, it will form, okay, optical fiber, where the properties of optical fiber is high compression strength and also flexible. Okay, so we proceed with the comparison between the photochromic glass with its original component. Okay, so glass is transparent and does not absorb heat. Does not absorb UV rays. Okay, so silver halide, which is silver chloride, okay, salt crystals such as silver chloride, okay, kan kita tahu perkataan halide tu, it's referred to the halogen. Okay, is transparent to visible light and absorb UV rays at the same time. Sebab itu bilanya ada je cahaya matahari, photochromic glass ni, okay, dia akan become darken. Okay, so glass, as you can see, dia punya properties transparent, okay, and then dia does not absorb UV rays, not sensitive to light. But for silver chloride, okay, dia punya properties is transparent to visible light, absorb UV rays, and sensitive to light intensity. So by combine glass and silver chloride, we will get the photochromic glass, where the properties was enhanced, which is transparent. Okay, photochromic glass can absorb UV rays. The absorption of UV rays depend on light intensity. So maksudnya semakin tinggi dia punya intensity, okay, cermin tu dia akan menjadi semakin gelap lah. Okay, semakin banyak UV rays yang akan diabsorb. Alright, so that is the comparison between the photochromic glass with its original component. Then last but not least, okay, let's we proceed with the comparison between the superconductor yttrium, barium, copper oxide with its original compound. Okay, original component. Alright, so as you can see, okay, yttrium carbonate, copper carbonate, barium carbonate, oxygen, property, okay, untuk keempat komponen ni, alright, high electrical resistance at a room temperature. Okay, high electrical resistance at room temperature. Okay, but okay, when it's become to superconductor YBCO, okay, property was enhanced where no electrical resistance at a very low temperature. Okay, kalau kat sini room temperature kan, okay, dalam suhu 25, dia punya electrical resistance sangat tinggi, but bila dia jadi superconductor YBCO, dia punya property tu dah di-enhance kan. So, tidak ada lagi electrical resistance at a very low temperature. Maksudnya, even it's di bawah room temperature pun, no electrical resistance. Okay? Alright, so that's all untuk comparison between the superconductor with its original component. Okay, so setakat itu dulu untuk 8.4 composite and its importance. So we have the exercises here. Okay, please do test yourself 8.4 and please discuss with your teacher. So that's all from me, okay, Sir Azra, for this video. Thank you for watching. Assalamualaikum and selamat sejahtera.